Hey everyone, welcome to Ashis Academy. Today we are discussing about trigonometry. I listed down a couple of important topics. We will discover them today one after another. Let's get started. So the first thing we will learn about angle in a coordinate system. So what is an angle? If I just draw a coordinate system here, let's say this is x, this is y, and we have another ray. So basically angle is nothing but a one ray which is moved or rotate with respect to the another ray. So we can think of like PQ be a straight line for time being. It has been moved with theta degree anti-clockwise from x-axis. So PQ is actually creating an angle with x-axis theta degree. In general, like we always represent O as the origin, which is actually pointing at 0 point, and in anti-clockwise we always define this as a positive angle. If the straight line is on the other way, then we can treat it as a negative angle. But yeah, in coordinate systems, this is called first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So in the first quadrant, both x and y is positive. Second quadrant x is negative but y is positive, and then third, both x and y are negative, and in the fourth quadrant x is positive but y is negative. So yes, angle is nothing but when two lines are actually connecting on a point that is called vertex and they have certain rotations between them, then we can just simply say there is an angle between these two lines. Okay, now what is the definitions of sine, cos and tan? I mean, those are very important concepts, but before jumping to them, I think the main concept comes on the trigonometry was like it talks about the right triangle, because all the things is coming through the right triangle. So we just first define the right triangle first and then understand from there actually. So let me again create xy coordinate. I'm just creating another right triangle. Let's say the point is P with, you can assume, okay, this is A is your base, B is your height, and then the positions of P will be A comma B, because that was the coordinate in the xy first quadrant positions, and assume that it is creating theta degree angles with respect to the x. We know from the Pythagorean theorems the hypotenuse C is nothing but c square equals to a square plus b square, right? But we can define certain angles, like one of the angle is called sine theta. So you can think of like theta is the angle that was created by the hypotenuse and the base. Now sine theta is nothing but the ratio. So all the definition is coming with a ratio. So sine theta says like, okay, this is the ratio between your height divided by hypotenuse. So height is your b divided by c. Similarly, cos theta is nothing but a ratio that is between your base against hypotenuse. So base is your a against c. And then tan theta represents another ratio which is nothing but your height divided by base. So it says height divided by base. Now you can derive like, okay, then what it actually implies? It implies your b, that is nothing but your height, is c sine theta, a, which is nothing but base, that is nothing but c cos theta, and p is again a tan theta. Yeah, so they have a very important role when you just talk about vector and how they have it, like you in physics you already gone through this concept, like you have a velocity when you have a projectile motions, and then the vector has a two component at the same time. One is your horizontal component, another is your vertical component, and if there is the angle of the velocity has been thrown with theta, then we know like this comes as a v cos theta and this comes as a v sin theta, exactly on the same concept. Like you can clearly see here, the b component, which is nothing but the horizontal part, is actually the c sin theta. So c is nothing but here you can think of like a vector, or which has a particular value and directions. If I just think about what is the vector of c, it's square root of a square plus b square, that is its value actually, and it has a directions that is nothing but the theta degree against x axis. So we have a separate video on top of the vector and everything in physics. Please check out the videos, but in here I can clearly see that okay, sin theta, cos theta and tan theta is nothing but a ratio between multiple arms on the right triangle. Sometimes you can clearly see that we can just represent tan theta as a sin theta by cos theta, because it's giving you the same result, because sine is nothing but your b by c and cos is nothing but a by c. So if I just represent like that, so my bad, yeah, so if I just saying a by c, then c goes up and then I can cancel out and it goes to b by a. So basically height divided by base. Okay, so till now we discovered about what is angle in the coordinate system, how we can define sine, cos and tan. Then we can just calculate some of the values of these ratios, or the sine, cos and tan theta value. Okay, let's jump onto the value, how we can calculate the things. But there is one important thing, so I just want to mention it here. The tan theta, which you can see it here, is nothing but it's representing the slope. So you can clearly see it is nothing but giving you height by base. So how the particular line has been aligned with respect to the x axis can be driven by the tan theta, right? So we'll discuss more about this concept, because when we go through about the straight line, circle and all sort of things, then we can discuss more about tangent part, how the slope has been defined, and it has a close relationship with the slope. You might see the equation of a straight line where y equals to mx plus c, where this m is nothing but slope, is actually nothing but your tan theta. So we'll discover them in future lectures, but for time being it's just a hint to you, like yes, so tan theta is nothing but the slope of that particular line segment. Okay, let's go back to the angle calculation, or I should say the value of sin theta, cos theta, tan theta. Okay, let's think about a very simple example. Let's say I have a right triangle. Where both base and height is the same value. So if both are same, then it's naturally like this is 90 degree and this should be definitely 45 and 45, right? So at that time c square, which is nothing but the hypotenuse, is nothing but a square plus a square is 2a square. So c is nothing but square root of 2a, correct? So if I just put all the forms, like which is just discover, like what is the value of sine here, in that case sine theta is nothing but when theta is 45 degree, you can clearly see this is theta, which is 45 degree. So sine theta is nothing but what we say, it is nothing but height divided by hypotenuse. So what is your height here? Height is a and hypotenuse is square root of 2 by a. So if I just cancel out a, then it becomes 1 by square root of 2. Similar thing coming to the cos theta is exactly the base divided by hypotenuse. So base is again a, square root of 2 a, so it gives you the same result. What about tan theta? It's nothing but height divided by base. So height is your a and base is your a, so that gives you 1. So we can easily find out, okay, the tan 45 is actually 1. That gives a sense, like when there is a straight line that passes through origin with 45-degree angle, all the points, like you see, this is x, this is y, all the points is actually the same value, because the straight line equation was y equals to mx plus c, where c equals to 0 and m equals to tan 45 degree, which is nothing but 1. So it eventually becomes y equals to x. So we can easily derive from that concept basically. So all the points where x1 comma y1, x2 comma y2, they are same points, like x2 is same as y2. It could be, let's say, 5. So the point could be 5, 5, x1 equals to y1 equals to maybe 10. So this could be 10, 10, all sort of things. So all the x and y are exactly the same value when the tan 45 is there. And as it is going through the origin, so c was 0 actually. Now let's discover the other angles. What is the value of sine, cos and tan when the theta value is 30 degree or maybe 60 degree at that case? We can think in a different way. Let's assume we have a equilateral triangle where all the arms are actually same. For time being, we can consider that is nothing but 2a. So all the arms are actually 2a, and we just draw a perpendicular. So if you draw the perpendicular, actually speaking, both are a. So this is, my bad, this is a and this is a, because it divides into half. My picture is little bit on the right side, but yeah, you can think the right directions. So if it is a, then what is the height here? So from the Pythagorean theorems, we know height a square. So if I represent height is h, height a square is nothing but height a square plus a square equals to 2a square, which is nothing but 4a square. So height a square is actually 3a square. So h is nothing but square root of 3a. Great. So we got height here. Now tell me that what is the value of, so one of the interesting thing is here, as everything is equilateral, so all the angles, this is 60, this is 60, and this entire thing, if I just consider a, b and c, then acb is also 60. So I can just simply say abc, bac and acb, everything is actually 60 degree. But when I just create a perpendicular, like CO is perpendicular to AB, at that time it creates another small triangle. So what is the value of there? So what is the value of ACO and BCO? This is actually 30 degree because it divides into half, right? So now from this entire picture we can easily solve what is the value of sine 60, what is the value of cos 60, and what is the value of tan 60. So if you see clearly that the 60 degree angles is nothing but, let's say you can pick any of the 60 degree angles. Let's say I can just choose different color. Let's say I choose this as a 60 degree. Okay, then what is the value of sine 60 here? The value of sine 60 is nothing but, it's a, my bad, yeah, so value of sine 60 is nothing but your height divided by hypotenuse. So what is height here? Height is nothing but h, hypotenuse is nothing but 2a. So h is actually, we just discovered from here, it's nothing but square root of 3 by a by 2a. So sine 60 square root of 3 by 2. Then if we consider the cos 60, which is nothing but the base over hypotenuse. So base is A, like you can clearly see, this is our base. So this is our base and this is our hypotenuse, right? So everything we are calculating based on this triangle right now when we consider the 60 degrees thing. So yeah, so what is our base? Base is A, and what is our hypotenuse? It is nothing but 2A, right? So if I just simply cancel out, it's 1 by 2. What is sine tan 60? Tan 60 is nothing but, okay, I just put it a little bit down. Okay, so tan 60 is nothing but height divided by base. So if I just consider height is h divided by base is your a. So square root of 3a divided by a is nothing but square root of 3. Correct. So these are the values we can get from this picture. Now similar thing we can get for 30 degrees as well, right? So what is the value of sine 30? Now when it comes to the 30 degree, we can tilt the same picture in a different way. So the 30 degree is exactly this one. Now when it comes to this same picture with the other angles, then AO is becoming your height and OC becomes your base actually, right? So we can consider sine 30, then what is our height here is nothing but AO, and what is your hypotenuse? Hypotenuse is still same, AC. So what is AO is nothing but A divided by 2A, which is half. Cos 30 degree is again the base divided by hypotenuse. Now here the base is CO, this particular angle. This is your base for this 30 degree. So this is our 30 degree, just for your understanding. CO divided by AC. What is CO? Is nothing but h divided by 2a, and the h value is square root of 3a by 2a, so square root of 3 by 2. And what is our tan 30? Tan 30 is nothing but height divided by base. So height is our AO divided by base is your CO, right? So AO is A and CO is nothing but 8. So A divided by square root of 3A, which is 1 of square root of 3. So these are the three values we got actually. Correct. So now if I just put it in a chart, let's say I put into a chart here. Okay. So you can think of, I have three value: sine, cos and tan. We did not discuss about 0 degree yet. We'll discuss just a minute. So let's say this is theta equals to 0 degree, theta equals to 30 degree, theta equals to 45 degree, and theta equals to 60 degree, and theta equals to 90 degree. Okay, so we are filling this graph. So for time being we got 30, 45 and 60. So we can just put all the value whatever we got from this calculations. So at the very beginning we calculate 45 degree. So if you see here, this is our all the 45 degree when theta equals to 45. So I can just simply put the value here. Okay, so 45 sine 45 is 1 by square root of 2, cos 45 is 1 by square root of 2, and then tan 45 is 1. If I just put all the 60 degree value which we got it from here, so now sine 60 is nothing but square root 3 by 2, cos 60 is half, and tan 60 is square root of 3. Similarly we got sine 30 is nothing but 1 by 2, and then cos 30 is square root of 3 by 2, and tan 30 is 1 by square root of 3. Correct. Now we are just discovering what is the value of 0 degree and 90 degree. So you can imagine what is 0 degree means. Like, so for time being you can think of like what is a triangle. Only think of like, okay, it has 10 degree kind of things. For example, this value is for time being theta equals to 10. So you can clearly see the height is actually reducing when the angle is reducing, right? Because there is nothing, no much height, like when the angle is very close to 0. So you can think of like when theta is 0, your height actually becoming 0, and then your base and hypotenuse is actually the same, right? So if they are same, then how you can just define sine theta? Sine theta is nothing but height divided by hypotenuse. So in our situations, if I just think of this particular triangle, let's say ABC, so the hypotenuse and the base are actually same. So I can simply think of base B is same as hypotenuse, and as height is 0, I can clearly see the sine theta is 0 when theta equals to 0. Now what about cos theta? So the cos theta is nothing but it says base divided by hypotenuse, and both base and hypotenuse have the same value, so cos 0 is actually 1. What about tan theta? Tan theta is nothing but we just say sine theta by cos theta. So sine is 0 and cos is 1, which is eventually coming to the 0. So now we can just put the data here. So sine 0 is 0, cos 0 is 1, and tan 0 is 0, correct? And the same thing happens, like you can consider of like you have a triangle, a right triangle. Maybe this particular angle is almost close to, let's say this is 80 degree. You can think of like if it is almost close to 90, then there is no base at all, right? I mean, it's going to be like your height is actually colliding with your hypotenuse. So in that case, like if you just think in that case, like your base is actually becoming 0 when theta is tends to 90 degree, right? So we actually speaking, we can't draw a triangle if it is 90 degree because it's a straight line at the same. So you can just approximate it for time being. Now in the situations, what will be the sine theta? Sine theta is nothing but your height, height divided by hypotenuse. Actually both are actually same, so it will be 1. Cos theta will be your base divided by height, which is eventually 0 because there is no base, and tan theta is nothing but generally we speak about like sine divided by cos, so it is undefined because there is no way you can determine because the cos value is 0 right now. So if I just simply say and put the data, so sine 90 is 1, cos 90 is 0, and this is kind of undefined for time being. So in that way you can easily calculate all the values of sine, cos and tan using triangles basically. Okay, now we explore till 5 that what are the different values and there. Now let's talk about the 6th item. So we explore 1, 2, 3, 4, 5. Let's discuss about 6. What is the relationship between sine and cos? So there are multiple ways we can just relate this two ratio, but I think the easiest way we can just think of in like, okay, we have a coordinate system, we have a right triangle, let's say this is our base, this is our height, this is our hypotenuse, and the angle is theta. So just now we saw that sine theta is nothing but h by c, so that implies h equals to c sine theta. Similarly cos theta is nothing but b by c, that's why it implies base is nothing but hypotenuse into cos theta. Now one of the interesting thing you might see it here from the Pythagorean's theorem, we know the another relationship. What was that? Base square plus height square is nothing but hypotenuse square, right? So if I just think in that way, then I can replace base with all the values. So what is base actually? C cos theta whole square, and then height is nothing but c sine theta whole square is nothing but c square. I can just simply do square of all the things, so it's basically c square cos square theta plus c square sine square theta. So in the angle scenario, the squares when it is applied you can just put on the cos square. So basically this actually same as this. So for your understanding actually, okay, is nothing but c square. If I take a common of c square, then what we get, sine square plus cos square, because we take the common of c square, is nothing but c square. I just simply cancel out. Then what it becomes sine square theta plus cos square theta equals to 1. Great. So that is one of the good relationship between sine and cos, and we always get sine square theta plus cos square theta equals to 1. When we discover about, when we discuss about the graph, how we can plot all the sine and cos with respect to different angles, we can easily measure this quantity, like okay, it's always constant and the value is 1, like sine square theta and cos square theta is 1. In general, like as we discussed, when theta value is between 0 to 90, all the sine and cos value is actually between 0 and 1. Both sine and cos value is between that two. But when you talk about all the ranges, let's say between 0 to 360 degrees, basically all the ranges, if we just think about in that way, then the sine and cos will become between this range, will be always between +1 and -1. So yeah, we'll discuss more about them in just a second. Yeah, so this will be the range between the sine value and cos value actually. Okay, so we discussed about the sixth term, that what is the relationship between sine and cos, and we can easily find out a relationship between them, like sine square theta plus cos square theta equals to 1. There are a lot of other relationship as well, like we can just easily build on top of that one, but that was the primary relationships you can think of it. Let's talk about a little bit on the polar coordinate. That was also interesting concept. So what is polar coordinate? We can define, if we define a circle, so you can think of like, I have a point R, let's say R could be a vector which has actually A on the x directions and B on the y direction. So the point of R is actually A comma B. Now you can think of like using Pythagorean's theorem, R square is nothing but A square plus B square, because R was the hypotenuse, right, in the right triangle. But in another sense, you can also think of it like, I can easily represent, if I know the theta. So you already see that if I know the theta, then we know sine theta is nothing but B by R. So that says like B is nothing but R sine theta. Similarly, cos theta is nothing but A by R. That says A is nothing but R cos theta. So the point R, which is nothing but A comma B, can also be written like R cos theta comma R sin theta. So eventually we can represent the things with in terms of your R and theta. So a polar coordinate says like, instead of x and y, you can just also represent the entire circle into theta and R value. So anywhere in the circle, it is actually nothing but R and theta. So that is the way you can represent the entire coordinate system when we discuss about the circle. Interestingly, the circle equation is nothing but the Pythagorean equation. So any point which is, let's say you consider x comma y, if the circle is origin at center, then the circle equations is actually x square plus y square equals to R square. That is, we know, like that is the way the Pythagoreans work. So this is actually a circle equation when origin is at its center. Correct? So if origin is not at center, then generally the equations, like you can think of, I have x and y, and the circle center is at, let's say, C, which is for time being x comma y1, and let's say this is our circle. So my bad, I think it should be equally okay. So let's say x1 comma y1, and the circle could be, let's say, this one. Let's say everything is R. So in that time, as we know, the center of the circle is at x1 and y1 distance. We can assume that the entire coordinate system could be shifting to this particular point, and we can just assume there is a circle. So if we shift the coordinate system from origin to that particular positions x1 y1, then it's actually becoming the same use case which we discussed here, right? So then at that time, what will be the circle equations? It will be like we are shifting x1 and y1. So basically now it becomes x1 minus x1 squared plus y minus y1 squared is actually r squared, and that is eventually true, because if you see here at any instance of time, so this particular, let's say there is a point x comma y on the circle, and what is the base here? Actually, I should use a different color for better understanding. So what is the base? So base is this one, which is nothing but x minus x1, and what is height? Height is nothing but this one, which is nothing but y minus y1. That eventually says like, okay, I have r, right? So it's again coming to the same formula. Yeah, so if the circle is shifting to some other locations, the center, then the equation is changing a little bit, but yeah, at the very end it is the same circle equations. Okay, so that's great. I think we learned about how we can represent a polar coordinate. So polar coordinate to represent a particular point xy. We will be discussing about how we can put sine, cos and tan value in a graph. Before that, I think we already know what is the value of sine, cos and tan between the range when the theta is 0 to 90, but we did not discover about other quadrants, right? So we will be discovering for the other quadrant, and then we can put everything in the graph. Let's explore that part. Okay, great. So we are here right now regarding graph. Okay, let me change the color. Okay, I think, yep. So how we can think of graph here? So one of the way you can think of, okay, I have this x coordinate and this is my y coordinate. Okay, so at 0 0, so this is nothing but the x is representing theta. So I have a 0 degree here, and the next this could be, let's say, 90 degree, and this could be 180 degree. So if you think in full-fledged circle, so we have, this is 0 degree, this is 90 degree, this is up to 180 degree. So if you just think of like, okay, I rotate from here to here, that is 180 degree. If you rotate from here to here, then it becomes 270 degree, and if you rotate completely, then it's actually 360 degree, right? So that is the one way you can think of it. The other way you can just think of it, okay, I have 0 to 90, so this is 0 degree, this is 90 degree, this is 180 degree. It is we always consider in a positive rotation. So if it is anti-clockwise, then we can, against your x-axis, we can think of it as a positive rotations. You can think of it like, okay, this could be minus 90 degree, which is against x-axis but in a clockwise versions, and this comes here with minus 180 degree. So logically both plus 180 and minus 180 can give you the same result, because it's actually a straight it's a straight angle actually, but this is a two different way you can just think of it, like we can calculate it any way. So when you're putting it here, so 0, 90, 180, you can think of like there will be 270, and I'm just stretching it here, let's say there could be 360, but for time being if you just calculate this one, so 270 is actually between 180 and 270 is actually mapping the same thing, between same as a minus 90 to minus 180, right? So I can point it here minus 90, and then I have minus 180. Okay, so we already know the value between 0 to 90, so I'm just putting it, let's say this is 0 and this is plus 1, this is minus 1. So what is the value of sine 0 at 0? We know like it is 0, so I'm just plotting right now the sine function. What is the value of sine 30 degree, that is half? I'm just simply saying okay, this could be the half, and this is 30, this is 45 degree, this is 30 degree, this is 60 degree for timing, just separating out. So around 30 it can go to here, and then 45, we know sine 45 is 1 by square root of 2, so it is little bit bigger here maybe, and then 60 is square root of 3 by 2, and then 90 will be almost here, so 1. So it comes like this. Okay, what about, so this is about sine. What about cos? Cos at 0 was, I can just point out cos with different, let's say blue. So cos at 0 as 1. What is the value of cos 30 degree? It is sine 60, so square root of 3 by 2, so I think it's come around here, this and this, so it comes like this. But the interesting thing which we observe, so this is nothing but the cos theta, but we always know sine square theta plus cos square theta equals to 1. So anywhere if you just put any theta value and then check what is the value of sine and cos, you always get 1, their square value of 1. Now what about the value when it going beyond 90 to 180 degree? So basically in this zone, in the second quadrant, what about the value? So before jumping to there, I think one thing you can clearly see, both sine and cos are actually positive. Okay, now let's understand the situations when the theta is between, let's say above 90 degree and below 180 degree. Okay, so for that instance what will be the value? Yeah, so it comes to the second quadrant, and you can clearly see from the second quadrant we already discussed. So in the second quadrant, what is the value of x is nothing but it's negative, and y is still positive. And if you just imagine in a second quadrant there is, let's say, a theta, and if I simply say what is the value of sine theta here, so sine theta is nothing but your base divided, sorry, sine theta is nothing but your height divided by hypotenuse, and height is representing still y, so y value divided by hypotenuse value, so that is definitely still positive because this is still positive, y is still positive. But what about cos? So cos is nothing but base which is on the x-axis divided by hypotenuse, and definitely that will be negative value, and hypotenuse is still positive, so the overall things is negative. So the second quadrant, the value of sine is actually positive, but the value of cos is actually negative. Okay, so if we just try to find out what will be the graph for 90 to 180, so it will be for sine it will be very similar, like it will come like, sorry, it will come like this, and what will the value of cos? If I just think about between 80 to 90 to 180, it will come like this. So when it comes with the value is almost 180 degree, the cos value is actually -1. And what is the value of sine at 180? It will be 0 again. Now the same story goes for here as well. Like if you just see this particular quadrant, let's say fourth quadrant, right, where you can think of like you have a right triangle with theta, then what is the value is going to the negative flow? It's y is actually going to the negative, and what is the value of x? X is still in the positive, right? So x is positive but y is negative for fourth quadrant. And then what is impacting? Impacting is your sine theta, which is nothing but your height divided by hypotenuse. So height is actually negative, hypotenuse is still positive, so that's why sine is negative. What about cos? Cos is nothing but base divided by hypotenuse, and base is still positive and hypotenuse is still positive, so the overall outcome is positive. So the fourth quadrant, sine is negative but cos is positive when the theta value is actually between -90 to 0, so on the fourth quadrant actually. So now how the things will be graphed here? So we say that okay, fourth quadrant is nothing but actually 270 to 360. It's exactly same between -90 to 0, right? So it's going to the same flow like from here to here. Now how we can just simplify the things? We can clearly see that how the graph is going. So now sine, let me jump back to black in color for sine. So sine goes to -1 at -90, and what is the cos value between -90 to 0? Cos is still positive, right? So cos is still going to be positive. Yeah, cos is going to be positive. What about the third quadrant? If you see the third quadrant in here, in this particular zone, where both x and y are actually negative, so that's why in here both sine theta and cos theta are actually, the value is negative, right? So that is about the third quadrant when the theta belongs to -90 to -180 degree. So it's, I should say it's bigger. I mean in terms of your negative, I think I should say in the other way. So it should be, you can think of like in terms of your theta, it will be bigger than 180 but less than 270, or you can think of like it is -80 to -90, right? Because -90 is nothing but 270. Now in that time frame, how the graph will look like? So this is nothing but this particular zone, or you can think of this zone actually. So here the graph will be look like this. So it's again go back to here, so it goes back to here, and then the sine goes back to top. Yeah, just a second. Yeah, sine goes back to here. So you can just treat the same way. Yeah, so if I just draw the same thing in that side, so cos is actually going to bad black. This is our sine curve. It's coming here. Cos is going back here. Okay, black. This is about between 270 to 360, where in this range cos was positive on the fourth quadrant, if you remember. So it was this was +1, this was -1. So that is the way it's always going. Okay, so this is the overall graph, like you can think of like, okay, between 180 to plus 180, how the things is be looking like, sine and cos. So it is going infinitely, because this pattern is again repeating in this side, and this pattern will be again repeating on the other side as well, because we covered the between -180 to plus 180 degree. Okay, so this is about the graph, how the things will look like for tangent. Now tangent is nothing but, you know, like sine by cos or height divided by base. So if I just simply think of 90, 180 minus 90 minus 180, so it in the 90, I think it goes to, I mean in 45 degree, you know that the value is 1, and at 0 it is 0, but at 90 it is undefined, so it looks like something like this, and at the very similar phase, like it like this. At -90 it goes to this end, at +90 it goes to that end, same. Okay, now the final thing which we are discussing about the radian measure. Let's explore a little bit what is radian measure. So for time being, I just created a graph. You can assume that there is a circle which center is at origin, and then we know the circumference of a circle is nothing but 2 pi r, which is nothing but this entire area. We can start from 0 and then go to 90 and then 180 and 270 and then 360. So if I just think of like a radian is nothing but the angle where arc length is same as radius. So we this is the overall arc, right? So 1 radian is nothing but angle created by arc whose length is r. So r is nothing but your radius. So you can think of what is the, we already know like what is the ratio between total arc versus radius. It is nothing but, total arc is nothing but your entire circumference 2 pi r, and what is your radius r is nothing but 2 pi, right? So if I just simply put the radius here, let's say the angle which is created against x axis, this angle is actually called 1 radian. Okay, so what is the value of 1 radian then? So 1 radian is nothing but the angle created by the arc with arc length. So I know what is the overall circumference. This is nothing but 2 pi r. So I can just write it down in a different form. So I can say 2 pi r length creates 360 degree angle. Then our goal is like, okay, 1 unit of length creates 360 divided by 2 pi r angle. What we are actually looking for, we are looking for 1 radian, right? So 1 radian, which is nothing but arc length of arc, so I should say arc here, arc length of arc creates 360 divided by 2 pi r into r, right? So if I cancel out this r, then it becomes 180 degree divided by pi, and we know the value of pi is 3.14159. So if I just put this value, then what we will get, you will get approximately, I think, 51.8 degree. So this is nothing but 1 radian. So 1 radian is nothing but the angle approximately 52 degree is representing a 1 radian. Okay, so now we can clearly see that 1 radian is nothing but 180 by pi. So you can just cross section. So pi radian is actually nothing but 180 degree, right? So you can simply say pi by 2 radian is actually 90 degree, pi by 4 radian is actually 45 degree, 2 pi is actually representing 360 degree, right? So all the things you can measure in terms of your radian now. So that is a very meaningful way we can still represent an angle in terms of your radian. Okay, so yeah, so that is all about radian, how we can represent the radians. But the core concept of the radian is nothing but if you just create an arc with the length of your radius, how much angle it can produce, that is called 1 radian. That is nothing but your 51.8 or 52 degree, right? So and if you just put like all the arc, like all the arc one after another, you automatically get the entire 360 degree. So that is nothing but your 2 pi radian, which generates your 360 degree angle. Okay, so I think hopefully you learn a lot of things in these sessions. So we go through about how an angle has been generated into the coordinate system. We define sine, cos, tan. We find out the values of them, and then we find out the relationship between sine and cos. We define how can we just map a point xy into the polar coordinate system, and how you can just map all the sine, cos and tan into the graph, and also the radian measures. Okay, so thank you so much for watching this video and getting a good concept about the trigonometry. I just always take a moment to go to our Ashis Academy and then just discover what are the things we are learning in every single day. You will get a lot of discussions there. Also, if you have anything to share, feel free to share with us, and definitely please subscribe us and like it so that we can reach out to multiple science and mathematics based students like who really love science and math. And thank you a lot.